this video we are going to learn how to write a chemical formula. First, we will use the symbols of the elements, and the symbols as we can find them here in the periodic table. H is for hydrogen and Li for lithium. This periodic table gives us the symbols. So to write a chemical formula, we're going to use the symbols, not the words. And then the second step is that we're going to find the oxidation numbers. What is meant by an oxidation number of an element? For example, lithium here. Lithium, it is Li. It has 3 protons, so its atomic number is 3, which means it has 3 electrons. These 3 electrons are going to be arranged around the atom in the first shell 2. In the second shell is going to be the last electron and 1 valence electron. So every atom needs to have 8 electrons, but this atom has only 1. So it can gain 7 electrons to have 8 electrons and to be stable, or it can lose only 1 electron. So which is easier, to gain or to lose? To lose 1 is easier. So the oxidation number of this lithium atom is going to be an ion and is going to be positive 1 because it's going to lose 1 electron, which means it will have more protons which have positive charge than electrons which have negative charge. So all elements of group 1 have 1 valence electron. So all elements of group 1 will have a charge of positive 1. 1 positive, we will not write 1 because 1 positive means 1. And elements of group 2, they have 2 valence electrons, so they will lose 2 electrons. Is easier than to gain 6 electrons. So all elements of group 2 will have a charge of 2 positive, and this is the charge of these elements. Elements of group 3, this is group 3, they have 3 valence electrons, 1, 2, 3. So which is easier, to gain 5 or to lose 3? Well, to lose the 3 electrons is easier, so it becomes 3 positive. This group 3 becomes 3 positive. Now if we come to this side of the periodic table, these group 8, the noble gases, we will not talk about them because they don't react, they don't lose, they don't gain. But here right next to it is the halogens, and it is group 7. And elements of group 7, they have 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. So to have 8 electrons is easier to gain 1 electron. And to gain 1 electron, there will be 1 positive, there will 1 negative, sorry. So elements of group 7 will be 1 negative. And elements of group 6, they have like 1, 2, 3, 4, 5, 6. So to be 8, they need to gain 2 electrons. If they gain 2 electrons, there will be 2 negative. And elements of group, this one, 5, they have 5 valence electrons. So they will gain 3 electrons. So there will be 3 negative. This group 4, they share electrons, they don't gain, they don't lose, so we will not talk about them. We will not use the noble gases. What we need to know is only the oxidation of group 1. Elements of group 1, 1 positive. Elements of group 2, this is 1 positive, not X, this is positive, and this is 2 positive. Group 3, 3 positive. Group 7, 1 negative. Group 6, 2 negative. Group 5, 3 negative. And now we know how to find the oxidation number of these elements. We can use them to write a chemical formula of a compound. Let's look at this compound, sodium chloride, and we want to write the chemical formula of sodium chloride. So we're going to use the symbols. The symbol of sodium is Na and chlorine is Cl. Now we're going to look at the periodic table to see the oxidation number of these elements. Sodium is here in group 1, so it's going to be 1 positive. And chlorine is in group 7, so it's going to be 1 negative. Now we're going to write the charges above the element, sodium is going to be 1 positive and chlorine is going to be 1 negative. If we have the same number of charges, not the same charges, we have positive and negative, but we have the same number. Here we have 1 charge and here we have 1 charge. So these charges, or the number of the charges, balance each other. We need 1 sodium, and to balance that we need 1 chlorine is the same number, so nothing here to do. So this chemical formula of sodium chloride is NaCl. Now we're going to look at another example here. Magnesium chloride, magnesium, and this is chlorine. These are the symbols in the periodic table. Magnesium is in group 2, so the oxidation number of magnesium is 2 positive, and chlorine is in group 7, so the oxidation number of chlorine is 1 negative. Now we are going to write how to balance these. Magnesium has 2 positive, so magnesium have 2 charges too. But chlorine has only one charge. So how many of these chlorine we need to have to balance this one? So for 1 magnesium, we need 2 chlorine. 1, 2. This is 1 and this one. This has 2 charges. And to balance these 2, we need 1, 2. So how many atoms or ions of chlorine are going to balance 1 atom of chlorine? 2 atoms of chlorine are going to balance the atom of magnesium. So the formula of magnesium chloride is going to be magnesium Cl2. Why 2? Because we have 2 atoms. There is another easier way to write this one. If we write the charges, this is magnesium 2 positive and chlorine is 1 negative. Now we're going to use the cross method, in which everyone will take the valency of the other, will take the oxidation number of the other, so it can be balanced up. So magnesium will take the oxidation of chlorine 1, so magnesium will be 1. 1 is not written, we don't write 1, we just write Mg, it means 1. Now the chlorine will take the oxidation of magnesium, which is 2, so chlorine Cl will be 2. The formula of magnesium chloride is magnesium chloride MgCl2. Now let's look at another example to make it easier here. Magnesium oxide, magnesium here and oxygen is here, Mg and O. In the periodic table, we can find magnesium in group 2, so positive, and group 6, oxygen, is 2 negative. So the oxidation number of magnesium is 2 positive. The oxidation number of oxygen is 2 negative. Now, 1 atom of magnesium, because it has 2, will balance 1 atom of oxygen because it has also 2. So 1 atom or 1 ion of magnesium will balance the atom of magnesium. So we will not write any charge for them because they balance each other. So the formula of magnesium oxide will be MgO. But magnesium chloride, MgCl2. Why this is 2? Because the valency of magnesium is 2 and chlorine is 1. To balance this, we need 2. We need 2 chlorine to have the same charge or the same number of this magnesium. But here, because this has 2 and this has 2, they balance each other. Just keep it in your mind. If you have the same numbers, 2 here and 2 here, don't care about the charges, positive or negative. If you have the same numbers, then you just cancel them and write them without anything here. So this is another example here. We have aluminum oxide or aluminium oxide. Aluminum is going to be here El and oxygen here. In the periodic table, aluminum is in group 3, so it's going to be 3 positive, and oxygen in group 6, so it's going to be 2 negative. So we write the charges of these 2 elements above them. El is going to be 3 positive and oxygen is 2 negative. Now we're going to use the cross method and give each one the oxidation of the other. Aluminum is going to take the 2, the charge of the oxygen, so El will be 2, and the oxygen will take the charge of the aluminum, which is 3, so O3. The chemical formula of aluminum oxide is Al2, the charge of the oxygen, O3, the charge of the aluminum. Now let's look at another example here. If we have a group of atoms, when they join together, they have one oxidation number, and we need to learn these oxidation numbers of the groups. So we have sodium hydroxide. Sodium, we know it is Na, and hydroxide OH. The sodium, we already know it is 1 positive because it's in group 1. But the hydroxide, we have a table in the IGCSE book here. Look, hydroxide is NO3. The charge of it is negative. So, -1. The sodium is +1 and hydroxide -1. Because we have the same charges, they balance each other, so we will not write any subscript numbers. So, sodium hydroxide is going to be Na. OH, and this is the formula of it. Let's look at another one with a group here. We have sodium sulfate, and sodium, as we know, is Na, and sulfate is O4. The oxidation number of sulfate from the table we can find here, it is 2 negative. So sodium will be 1 positive and sulfate will be 2 negative. Now everyone will take the charge of the other. Sodium will take the 2, so it will be Na2. And sulfate, the sulfate, all the group SO4 as it is going to take the charge of the sodium, which is 1. So we will write this with 1, SO4, because it is 1, we don't write it. This is 1, we don't write anything in it. But if we're going to write any number, we're going to open bracket SO4. Then we write here 3, 4, whatever. If we write any number, then we're going to open brackets for this element to write it. And here I'm going to give you an example here. Magnesium nitrate. Magnesium is Mg and nitrate is NO3. Magnesium, the oxidation is 2 positive and nitrate is 1 negative. Now everyone will take the oxidation of the other. Magnesium will take the oxidation of the nitrate is going to be 1. So Mg1, we don't write it. And nitrate will take the 2, the oxidation of magnesium. And the nitrate now is going to be all this NO3 is going to be 2. It will take the charge of magnesium. So NO3. Now to write the 2, we said we'll open brackets and to write the 2, and now this 2 is going to be for everything inside of the brackets. This is how we write magnesium nitrate. Let's look at another example here. We have calcium phosphate, and calcium phosphate, this is calcium and this is phosphate. Calcium, the oxidation number of calcium is 2 positive. And phosphate, from the table, we'll find that it is 3 negative. Now calcium will take the oxidation of phosphate, which is 3. So it will be calcium 3. And the phosphate, all of this PO4 will take the oxidation of the calcium, which is 2. So we will write here bracket PO4 as it is, then open the bracket and give it the oxidation of calcium, which is 2. And if we will not write any number here for the whole group, we will not open brackets. So if you write aluminum here, El, it is 3, and phosphate is PO4, it is also 3. This is 3 positive and this is 3 negative. Now because they balance each other, we will not write these numbers, so it will be El PO4. I will not open brackets here and write anything, because if I will not write here anything, I will not open brackets. This is one of the most common mistake that many students make when they write chemical formulas. I hope that was fine and clear. Until the next video, ciao.